So today we're going to discuss matrix multiplication because this is a common practice when we're using group theory. So a matrix is simply an ordered array of numbers. This matrix on the left is considered a 3 by 3 matrix, and the matrix on the right is considered a 2 by 2 matrix because effectively on the left there's 3 rows and 3 columns. And on the right, there's 2 rows and 2 columns. So that's where you get 3 by 3 and 2 by 2 respectively. Each of the numbers contained in the matrix are matrix elements. So every single value that you find is basically an element. And when you're multiplying 2 matrices together, effectively what needs to happen is the number of columns in the first matrix has to be equal to the number of rows in the second matrix. So let's look at how you go about doing matrix multiplication. So the product matrix is going to be this C, which is the one that we got down on the bottom right here. And that will have I rows and J columns. But what determines the number of rows and columns in the product matrix has to do with what composes it in the first place. So you get the number of rows from matrix A. So this has 3 rows. And then you get the number of columns from matrix B. And matrix B has J columns. And that's 1, 2, 3. So you're basically multiplying a 3 by 3 matrix by another 3 by 3 matrix. And in fact, that simply gives you a 3 by 3 matrix in terms of the product. So let's actually look at what happens if we do some multiplication and how does this work. Well, when you're multiplying matrices, you get what's termed the dot product. Now, what the dot product is effectively taking, as you can see, the sum of everything that's contained in the first row in matrix A, and you're going to multiply that by the corresponding values that are contained in the first column in matrix B. So simply stated, this is going to be, 5 times 2 plus 1 times 1 plus 3 times 5. And that gives you the first element in matrix C, which is 26. Now, if we try a little different approach, so let's take the first row in matrix A and multiply it by the second column in matrix B. And you can kind of see where this is going. This is going to wind up giving you the value because you're talking about the first row, column 2, you're going to represent the dot product in the first row, column 2 in the product. And again, that's going to be 5 times 1 plus 1 times 2 plus 3 times 4. That all sums to 19. And that's really all you need to do to multiply 2 different matrices together. In a more general formulation, let's take a look now at what happens if I now pick the third row in column A and the first column in B. And you can kind of see where this is going. Because this is the third row, I is going to be 3. So we're going to be entering the value for 19 right here. And the way that this is going to work again is 1 times 2 plus 2 times 1 plus 3 times 5. That adds up to 19. And that gives you the dot product for multiplying row 3 in matrix A by column 1 in matrix B. And that gives you the position here of effectively the third row, first column entry. And it's as simple as that, really. There's no tricks to this. You just have to remember multiply rows in the first matrix by the columns in the second. So more generically, what happens if we sort of now have a 3 by 2 matrix multiplied by a 2 by 3 matrix? And that's exactly the point, is recognizing the fact that the number of rows dictates the number of rows in the product matrix. So there's 3 rows in matrix A, and there's of course 3 columns in matrix B. So that gives you the 3 columns that are represented here. And then you can basically calculate all the respective dot products. So this is all of the respective dot products just laid out. I'm not going to read them through one by one, but just prove to yourself that this math is all correct. And I'll just do one representative example here. So now if we take the second row in matrix A multiplied by the third row in matrix B, we should basically return the dot product that will give us the second row in column B and the second row in the product matrix and the third column matrix element, which is right here. And you can kind of see that's exactly the way it lays out. And that would effectively be, again, A21 times B13 plus A22 times B23. Sum of that is the value of the matrix element that's in the product matrix. And in this course, what we're going to see is we're going to use a lot of what are also called identity matrices, but many times we're going to do a 3x3 matrix to define X, Y, and Z coordinates. And then we can multiply it sort of by either a scalar or by another simple 1x3 matrix to sort of show how the operation is going to transform once we start talking about character tables. So thank you very much for your attention today, and I will continue this in the next video. Thank you for listening.